Hello. In this video, I'm going to be going through the CodeCheck Python Exercises, the assignment Week 11 Tables. In an 8x8 table for a game board, there are the following positions, assuming rows grow downward and columns to the right. Or where are the following positions, assuming rows grow downward? So we have rows top to bottom and columns left to right. Enter the row and column indices or indexes without brackets. Without brackets, interesting. So I assume it'll be like R row, comma, column, R, comma, C, like that. Top left corner is going to be 0, comma, 0. Bottom left corner is going to be bottom, so length 8 minus 1 is index 7, is going to be the row. So usually it's row, comma, column. So it would be row 7, comma, column 0. Top right corner would be this one here. So first row 0, row, column 7. And bottom right is going to be the last one we haven't done, 7, 7 with a comma. Looks good. Indicate whether each of the code segments shown accomplishes the task below it. Row equals 0 times columns, so it's going to be like 0, 0, 0 up to the number of columns, zeros. Table equals row times rows, so we take that row and multiply it by the number of rows. That's just going to make one flat thing that's the size of rows times columns, but it's not going to actually be a grid. It's just going to be one flat list. So I think no, that doesn't. Yes, it creates a list that contains rows times columns number of zeros. Instead of having like a 8 by 8 grid, it's just going to be a 64 or 8 times 8 length list that's flat. Flat would be meaning it's not nested, it's just all on one level. We now are making columns sized 0 array or list, and then table is row in brackets times rows. So now we're saying multiply that item being not just row, but a list containing row. And that list containing row, I think that would be like adding the row in brackets to itself multiple times, and adding a list to itself does concatenate the list. So I think this does do it. All elements of the table are references to the same row. Ooh, if you set table 0, 0 to 1, then table 1, 0, table 2, 0, and so on are 1. So this is clever. So we need to create actually new rows that are copies of that one. Honestly, I don't know if I knew that. Metals equals all this stuff, nested lists, so it's 2D. Print len metals at 0. So metals at 0 is going to be the first row, the entire first row, and that is going to be of length 3. Prints the number of columns in the table. Yes, it would, assuming that all of them are like the first row. And then prints the elements along the diagonal, joining the upper left and lower right corners of the what does that even mean? Prints the elements along the diagonal, joining the upper left and lower right of the metals table defined in the previous item. So we have 0, 0, row 0, column 0, row 0, column 3, row 3, column 0. That's going to be the 4 corners. Prints the adjoining the upper left and lower right corners defined in the previous items. I don't know. Along the diagonal, I think it excludes what's in the middle. So I think no. 4 corners, yeah. 4 corners, but not the diagonal. All right, so full credit. We need to start over. So it does not do that. It does not do that. It does do that, and it does not do that. Consider an 8x8 table for a board game. Initialize the board so that zeros and ones alternate as on a checkerboard. 0, 1, 0, 1, 0, 1, and then 1, 0, 1, 0, 1, 0. Rearrange the following lines to produce a solution. Okay, so we're going to need nested for loops. So we'll do we don't need to do anything in range 64 because we're doing 8 at a time, the rows and the columns separately, but nested to get that multiplicative effect to 64. Conventionally, people choose I first instead of J, and then they choose J second, just by convention. And I is typically used for row I, and J is typically used for column J, just conventionally. And so that's why they were doing brackets I before brackets J. If we did the nesting of the for loops in the opposite way, then this would be opposite. I don't know what my phone is doing. So we'll start with board I. What is happening? Who's to say why my phone is beeping? I can't tell you. Okay, so the board at ij will be I mod 2 plus j mod 2. All right, so we're saying mod is saying if our current position is divisible by 2, it's either going to be divisible by 2 and we get remainder 0, or it's going to be not divisible by 2 and we get remainder 1. So we want to start with a 0. So at 0, which is even, where mod 2 is 0, then we get 0 plus 0 is 0. So that's likely to make sense. Because I guess we need to know if we're in an even, if we were in I equals 1, so row 2, or the 1 index row. If I was 1, then mod 2 would leave us with 1, but j mod 2 would leave us with 0. But if we had 1, 1, like if we were in row index 1, column index 1, we would get mod 2 is 1 and mod 2 is 1, and then we would be putting a 2 in there. And so putting a 2 in there never really makes sense. So maybe I plus j mod 2 makes more sense to say wherever we are, if the sum of the indices is even, it'll be 0. If it's odd, it'll be 1. So the sum at 0, 0, the sum is 0, and that's even, so we go 0. At, let's say, 2 and 0, 1, 0, 1, 2, so the third row, column 0, 1, 2, 3. Then we have 2 plus 3 is 5, which mod 2 is 1, so this seems like a plausible option. And of course I got rid of it. So for I in range 8, j in range 8, sum mod 2, done. That was actually a little bit challenging. Try out the following activity to learn how to visit all elements in a table. This code counts how many table elements are negative. Rows equals len a, cols equals len a at 0, so the first element of A, meaning the length of the first row, so the number of columns, length of the first row or the last row or the second row or whatever, it doesn't matter. We're just picking the first one. Count is 0, I is 0. Well, I is less than rows, so we're iterating through the rows vertically. J is 0, well, J is less than calls, iterating through the columns of each row iteratively. If the current cell, so the thing at row I, column J, is negative, then increase the negatives count, increment the loop, increment the other loop. So what are we even doing? Try out the following activity. What do you mean try it out? I'm not even sure what we're supposed to do here. Try out. The code counts. Yep, I'm not seeing an activity, guys. So I'm not sure if this is some kind of mistake or if there's actually no activity here, but we traced the code, read through it, understand what it's doing. Doesn't seem to be anything to complete here. Write a function that fills a given table with the multiples of 5, starting with 5 in element 0, 0, 10 in element 0, 1, so row 0, column 1, 15 in element 0, 2, and so on. For example, if the table contained 3 rows and 5 columns, it would be like this. All right, fill table dot py main table equals open close brackets for I in range 4. Why are we doing 4? Fills a given table with the multiples of 5. Oh, okay. So wait, so table for I in range 4, row equals 6 zeros, append row, so it's a 4 by 6. And then table 2 is 7 by 3 of zeros, so 4 by 6 and 7 by 3, just making examples, I guess, and fill those with multiples of 5. Okay, so should be pretty simple. For I in, and we could use anything, they always use I, but we could use for row index in range len values, so just the number of rows, and then we're actually going to have to get a particular row for the next one. So let's say row, or first row, is going to be row values, or honestly, it doesn't, we could use any row. It could be the first row, or we could say current row is going to be values at row index. And the num calls, or we could just do it in line. So we'll do for call index in range len current row, or first row for that matter, or last row, it doesn't matter, just something to iterate through the column indices. So now we have row index and column index. And in some situations, you would think you could do something like this, like values at row index, comma, column index. You cannot do that, so you have to do this first set of brackets to get this the first row, and then from a given row, and then for that row, get the particular column in that particular row with another set of brackets. And so we're going to set that equal to what? Well, it's going to be 5 times something, and it'll be 5 starting with, okay, so we're wrapping down to the next one. So honestly, we're just keeping a continual 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. So in this one, we have 0, 1, 2, 3, 4, but we're getting 5 times 5. So we basically need I plus 1 times 5. That's not going to work for everything, but that'll work at first. So we want this to be 5 times I plus 1, maybe. But that's not going to work when we get down here, because then we would just, again, go 5. We would just go 5, 10, 15, 20, 25, but we want to go 30, etc. So the change here is going to be, we know where we'll be starting. We'll be starting 5 off of, based on the given column we're at, so so the row that we're at. So row 0, we're starting with an offset of 0. On row 2, we're starting of an offset of, well, honestly, we could just keep track. We don't even have to compute it by the index. We could honestly just keep track of, we're always adding 5. We're just continually adding 5, starting at 5, and then, yeah, that would be the easiest way to do it rather than doing some weird math with the index. So I would just say, let's say like recent or last filled equals, and we'll just start it at 0 or 5. And we'll say the first time that we get to anything, it's going to be last filled, and then we're going to take last filled and plus equals 5 so that it's larger by 5. And then whenever we get back to this, regardless of what row and column we're on, it should work, I believe. They only gave us one test case, so hopefully we got that right. And that is everything for this assignment. Thanks for watching.